Hey there, science fans! Welcome to another exciting journey into the world of technology. Have you ever held a microchip in your hand? They're tiny, almost like a speck of dust. But don't let their size fool you. These minuscule components are incredibly complex and powerful. These little guys are the brains behind almost all our gadgets. From the moment you wake up to the time you go to bed, microchips are working tirelessly to make your life easier. Smartphones, laptops, cars, even your refrigerator, they all rely on microchips. Imagine a day without these devices. It would be like stepping back into the Stone Age. These tiny wonders are packed with millions, even billions of transistors. Each transistor is a marvel of engineering, acting as a tiny switch that can turn on and off at incredible speeds. Transistors are like tiny switches that control the flow of electricity. They are the fundamental building blocks of modern electronic devices. They're what allow our devices to compute, remember, and communicate. Without them, we wouldn't have the advanced technology we rely on today. Ever wonder how these intricate brains are made? It's a fascinating process that combines science, engineering, and a bit of magic. Buckle up because we're about to take a wild ride through the fascinating world of microchip manufacturing. From raw materials to the final product, each step is a marvel of modern technology. We'll start with plain old sand and end up with the powerful chips that power our digital lives. It's amazing to think that something as simple as sand can be transformed into the brains of our most advanced devices. Get ready for some serious science. We're about to dive deep into the world of microchips, where every tiny detail matters and the possibilities are endless. So, stay tuned, and let's explore the incredible journey from sand to silicon. Our journey begins with a humble ingredient: sand. But not just any sand. We're after sand with a high concentration of silicon dioxide, also known as silica. Think of it as the main ingredient in our microchip recipe. This special sand is mined and then goes through some serious processing. It's heated to super high temperatures to extract pure silicon. Imagine a giant oven baking out all the impurities. The end product? Shiny, purified silicon in a solid form called a silicon ingot. It looks kind of like a giant metallic sausage. This ingot is the building block for our microchips. Now remember that silicon ingot? It's time to slice it up. The ingot is carefully sliced into thin, round discs called wafers. Think of these wafers as the blank canvases for our microchips. This slicing process requires incredible precision. The wafers have to be incredibly thin and perfectly uniform. Any imperfections and the chip won't work properly. We're talking about slices thinner than a human hair. Talk about delicate work. Here's where things get really cool. Remember those intricate circuits on a microchip? They're created using a process called photolithography. It's like using light to paint circuits onto our silicon wafer. First, the wafer is coated with a light-sensitive material called photoresist. Then, a detailed pattern of the circuit is projected onto the wafer using ultraviolet, UV light. Think of it like creating a stencil with light. The areas exposed to UV light harden, while the unexposed areas remain soft. This creates a pattern on the wafer that will guide the next steps in the process. Section 5. Chemical carving and doping, refining the circuitry. This is where the magic happens, transforming raw materials into the sophisticated components that power our modern world. With our light-painted pattern in place, it's time for some chemical etching. This step is crucial as it defines the intricate pathways that will guide electrical signals through the chip. The wafer is dipped into a special chemical solution that washes away the soft, unexposed areas of photoresist. This process is akin to a sculptor chiseling away at marble, revealing the masterpiece within. This leaves behind the hardened pattern, revealing the underlying silicon. The precision of this step cannot be overstated, as even the smallest error can render the entire wafer useless. It's like using a chemical chisel to carve out the intricate circuitry. Next up is doping. This is where the real alchemy begins, turning our etched silicon into a functional microchip. This is where we introduce tiny amounts of impurities into the silicon to change its electrical properties. These impurities, or dopants, are carefully selected to enhance the performance of the chip. It's like adding spices to a recipe to enhance the flavor. Just as a pinch of salt can transform a dish, the right dopants can significantly improve the chip's efficiency and speed. Doping creates the transistors, the tiny switches that control the flow of electricity, bringing our microchip to life. These transistors are the building blocks of all modern electronics, from smartphones to supercomputers. Each step in this process is a marvel of engineering and precision, culminating in a microchip that can perform billions of calculations per second. This is the heart of our digital age, the silent workhorse behind every electronic device we use. Section 6. From wafer to chip cutting and packaging the brains. Remember those thin wafers we started with? They're now covered in a whole bunch of identical microchips. It's time to separate them. The wafer is carefully cut into individual chips using a diamond saw. Think of it like cutting cookies from a giant cookie sheet. Each tiny chip is now ready for its final touches. To protect them and allow them to connect to other components, the chips are encased in protective packages. These packages have tiny wires that act like bridges, connecting the chip to the outside world. Finally, our microchips are ready to go out into the world. Section 7. Testing. 1, 2, 3, ensuring quality performance. Before we ship out our microchips, they go through rigorous testing. We gotta make sure they work flawlessly. The chips are subjected to different temperatures, voltages, and other stressors to simulate real-world conditions. Think of it like a microchip boot camp. Only the strongest and most reliable chips make it through. Any chip that doesn't meet the high standards is rejected. Once the chips pass all the tests, they're ready to be shipped out to companies that will use them to build all sorts of amazing devices. Section 8. The global dance of microchip manufacturing. Making a microchip isn't a one-man show, folks, it's a global dance. Different companies specialize in different parts of the process, from designing the chips to manufacturing the equipment used in production. Raw materials come from all over the world and finished chips are shipped to every corner of the globe. It's a testament to human ingenuity and collaboration. Section 9. Moore's Law and the future of miniaturization. You know what's amazing? Microchips have been getting smaller and more powerful over time. It's like magic, but it's actually science. There's this idea called Moore's Law, which states that the number of transistors on a microchip doubles approximately every 2 years. This means our gadgets can get smaller, faster, and more powerful over time. Scientists and engineers are constantly pushing the boundaries of miniaturization, finding new ways to cram even more transistors onto these tiny chips. The future of microchips is all about doing more with less. Section 10. Environmental impact and sustainability in chip making. Now let's get real for a second. Making microchips requires a lot of energy and resources. The chemicals used in some processes can be harmful to the environment if not handled properly. But hey, the good news is that the industry is becoming more aware of its environmental impact. Companies are constantly looking for ways to reduce their footprint by using cleaner energy sources, recycling materials, and developing more eco-friendly manufacturing processes. It's all about finding that balance between technological advancement and environmental responsibility. Section 11. The marvel of microchips, a recap and appreciation. So there you have it, folks. We've taken an incredible journey through the world of microchips. From humble grains of sand to the powerful brains behind our digital world, the transformation is nothing short of magical. The journey of microchip manufacturing is a testament to human ingenuity and innovation. It's a process that involves countless hours of research, precision engineering, and meticulous craftsmanship. We've seen how silicon is transformed from a raw material into a polished wafer, ready to be etched with intricate circuits. How light is used to paint circuits onto these wafers, creating the pathways that will carry information at lightning speeds. And how these tiny chips are rigorously tested to ensure they meet the highest standards of performance and reliability. It's a complex and intricate process, involving multiple stages of production and quality control, but it's also incredibly fascinating. Each step is a marvel of modern science and engineering. Next time you pick up your smartphone, remember the journey it took to get there. Or fire up your laptop, think about the countless innovations and breakthroughs that made it possible. Take a moment to appreciate the marvel of microchip manufacturing. These tiny wonders are the unsung heroes of our digital age. These tiny wonders have revolutionized our world, enabling everything from smartphones to supercomputers, and continue to shape the future. As we look ahead, the future of microchips promises even more exciting advancements. Engineers are already working on next-generation chips that will power the technologies of tomorrow. So keep asking questions and stay curious. The world of microchips is ever evolving, and who knows what amazing innovations lie just around the corner.